Hello, we are EROR Semiconductors, and today we would like to talk about computers, a staple of modern society and technological prowess for nearly a century. Their ability to process large amounts of data has become faster and faster with every year. This increase in computational ability is epitomized by Moore's Law. Moore's Law is an observation made by Gordon Moore, the co-founder of Intel, 54 years ago, which stated the number of transistors per square inch on an integrated circuit has doubled every year since the integrated circuit was invented. And for around the last century, this has remained true. However, a shocking report in 2013 showed that Moore's Law was slowing down, and by 2028, reduction in size of transistors would have stopped almost completely. But to first understand why Moore's Law is slowing down, we must understand what a transistor is. In the most basic sense, a transistor is a switch. This switching action is the basis for all of modern computing. The problem comes when we shrink the components so small that we encounter a phenomenon in quantum mechanics called quantum tunneling. This is where electrons pass through a component or barrier without any resistance. Go back. Think of the transistor as a switch. Quantum tunneling allows for the electricity to pass through the switch even when it is off. Now, how does this affect you? This means that computers will no longer get smaller and faster at the same time. Now, what is EROR Semiconductors here to do? Well, we have designed a transistor with three main selling points. Firstly, any processor that uses our transistor will have reduced heat emissions. Our transistor is no more expensive to produce than the modern industry standard. And finally, we can produce a transistor 1/7 the size of the modern day industry standard, whilst mitigating the effects of quantum tunneling. Now, we were unable to produce a prototype for two main reasons. Firstly, chemical restrictions in Dubai do not allow us to import the chemicals necessary to produce semiconductors. And secondly, we were unable to acquire the specialized and expensive machinery necessary to produce semiconductors on such a small scale. So, in lieu of a prototype, we contacted Dr. Stephen Wilkinson, a professor of chemical engineering at Wollongong University of Dubai, who stated, we would be able to produce our transistor at 2.5 nanometers whilst maintaining the integrity of the switching action. So, how are we going to monetize this product? Well, we limited our monetization strategy to two possible options. Firstly, we could approach an established manufacturer to produce and sell our product. And we would receive royalties for either every sale or product produced. They would target the corporate sector due to their need for high processing power in a limited space. Now, we see this to have two main advantages. Firstly, we would be able to access higher earning clientele. And secondly, we would not have to deal with sales or production of our transistor. For our second option, we would produce processors for aviation, consumer electronics, and most interestingly, augmented reality, due to their need for high processing power in a limited space. Now, this would not be as lucrative. However, it would allow us to maintain control of our product and who manufactures it. I'd like to avert your attention to the graph for Plan A. Plan A is shown to be more lucrative, have faster profitability, and the exponential increase you see there is based off of Intel's growth predictions for the next 30 years. If you look at Plan B, it is less lucrative, however, has a steady profitability and is less risky. Now, let's talk numbers. The semiconductor industry is estimated to have a compound annual growth rate of 5.1% between the years of 2017 to 2025. The overall export value of China's semiconductor industry in 2016 was $75 billion. Air Semiconductors product is in high demand because of the public's increasing need for higher processing capabilities in their products. Air Semiconductors is rivaled by massive corporations like Intel, Acer, AMD, and Samsung Electronics. However, where they are unwilling or unable to innovate, we have made great bounds ahead of them, making us a very attractive investment. This is the dedicated team that will take our transistor to the front line of computational technology. We have me, the CEO of Air Semiconductors. You have Arav Sethia, our project manager and CFO. And finally, you have Elliot Abramo, the COO and lead electrical engineer. Let's take a look at the past, present, and future of Air Semiconductors. In 2018, we began research of our idea, and just this year, we launched our startup. By early 2020, we would like to produce our initial prototype, and by late 2020, we would like to partner with an established manufacturer to produce our processors. And by 2021, we would like to have a product on the market. Welcome to the next century of computational ability. That's a very good question. It's kind of an established viewpoint that Moore's law and quantum tunneling has stopped any reduction in the size of semiconductors. However, our very specialized design has allowed us to mitigate those effects.
Yeah, so why did you come up with that and not decide that people working in companies not yet?
Well, IBM and Intel released a report saying that instead of focusing on a new design like Air Semiconductors, they've been focusing on the energy efficiency of existing transistors before them going to focus on an entirely new design. So what we have planned to do is step directly into the future and launch a new design that is faster, smaller, and no more expensive to manufacture.
Okay. Second question. You would be the first high-tech company that we work with, but unlike some of these kind of software companies, you're going to raise millions of dollars before you get any traction. And you found that young people have a credibility deficit. Now, because a couple of them, the companies we work with, they have a very specific plan about where they're going to get money, how they're going to about doing it, how they're going to get credibility without traction. So what is that plan?
Well, okay, the first point is, no, we don't actually need a high amount of capital because... Okay. But relative to producing an entirely new product, if we went with plan A, like you saw beforehand, we would only have to produce an initial prototype, and then we'd have to market it to a larger company like Intel, Acer, or AMD. And then, what was the rest of the question?
The main question is, do you have any specific, say, grants or other funding sources, or other ways to kind of get credibility without traction? Because you can't tell us
Well, if we were to win this competition, this would give us a lot of traction. However, we do have partners that we can work with who have connections to people like Intel, AMD, and we have also established to meet with a group of professors who would look at our design and give us feedback and then give us credibility on whether or not our product would work.
Yeah, I think my question is similar, right? For us, or for investors,
We would produce an initial processor using our transistors, and then due to we would produce it in the same size as a modern day processor, and then we would show the difference in processing capabilities to an industry standard and our product.
But even using labor is going to take millions of dollars.
Yeah, it would be an expensive endeavor, and we would need, relative to a lot of these companies, a high amount of capital to produce our product.
Let's say you guys catch the attention of like in-house attendees. How will your leasing model work entirely? Because they will have a lot of resources on hand to, let's say, use your chip first and then develop their own. Doesn't have to have any overlap whatsoever. So how will you stop this copying? Or how will you stop them from developing their own or iterating from the chip?
Can I clarify? Do you mean like in terms of legal issues, or?
Well, in a way, IP.
Yeah. Okay, so completely. AMD, Intel could take our idea and rip us off completely. However, there's one point that companies like this are very afraid of, and that's a PR issue. If they were to steal our idea, the PR lash that would come from that would be a lot greater than the relatively small amount of money they'd have to put into R&D with us.